I'd like to give you an example from the assignment, page 226, number 24. They want the exact value of the sine of a negative 13 pi over 12. Well, you'll have to realize whenever they ask for exact values, they're probably looking for special angles. So remember, the tangent is equal to the sine or the cosine, which is the square root of 0, 1, 2, 3, 4 over 2, and the square root of 4, 3, 2, 1, 0 over 2 for 0, pi over 6, pi over 4, pi over 3, and pi over 2. So we're looking for fractions of 6, 4, 3, and 2 for twelfths. Almost all of those will work. Let's see. We need, it'd be the 2 twelfths is the 1 6. 3 twelfths is the 1 fourth. 4 twelfths is the 1 third. And 1 half is 6 twelfths. We have to have something that's got to give us 13 of those 12ths. Well, remember, it doesn't have to just be these. How about if we do a 10 twelfths and a 3 twelfths? That'll give us 13. So, the sine of, we need a negative 10 twelfths pi minus 3 pi over 12. Now we apply the sign of a difference. It's the sign of the first. First of all, I guess, let's write this reduced. So this becomes 5 pi over 6. And this is now pi over 4. Okay. So now, the difference. Sine of a negative 5 pi over 6. Cosine of pi over 4. Use the same sign minus. Cosine of a negative 5 pi over 6 and the sine of pi over 4. So, remember, the sine of a negative is a negative sine 5 pi over 6 and cosine of pi over 4. But the cosine of a negative is just the cosine, 5 pi over 6 and the sine of pi over 4. Okay. Now, pi over 4 comes directly from this, but the 5 pi over 6 is in quadrant 2. So, 5 pi over 6 is just the same as pi over 6, except the signs will be the second quadrant signs. So, the sine of 5 pi over 6, the sign is positive in the second quadrant. Pi over 6 is 1 half. The cosine of pi over 4, square root of 2 over 2, minus the cosine of 5 pi over 6, that's going to be negative. But the pi over 6 is square root of 3 over 2. And the sine of pi over 4 is the square root of 2 over 2. So we have negative square root of 2 over 4 plus, because these negatives cancel, square root of 6 over 4, or negative square root of 2 plus the square root of 6 over 4. And that should be the same in the back of the book, except this is an even, so it's not in the back of the book. So that's an example of those types of problems. Look at the next video for examples of the next type of problem. Trigonometry. Problem 32 is an example, section 5.4, page 226. We're supposed to find the exact value of this expression. Well, first of all, we have to recognize this is a tangent sum identity. So this is the tangent of 5 pi over 12 plus pi over 4. If you recognize that, the rest of this isn't so bad. We've got to combine these two things. How many pi over 12s is pi over 4? The tangent of 5 pi over 12 plus times 3 pi over 12. So 5 and 3, this is really the tangent of 8 pi over 12. Let's reduce that. Tangent, if we divide both by 4, 2 pi over 3. So, if we remember, where's 2 pi over 3? That's in the second quadrant. 2 pi over 3. So, all of our values will have those plus and minus signs. Remember, this is a pi over 3 for the reference angle. So, remember our tangent is the sine over the cosine, which is the square root of 0, 1, 2, 3, 4 over 2. And this is the square root of 4, 3, 2, 1, 0 over 2. For 0, pi over 6, pi over 4, pi over 3, and pi over 2. You write that enough times, you'll get used to it. So we want the pi over 3 stuff. The tangent is the square root of 3 over 2 over 1/2. Invert and multiply the square root of 3 over 2 times 2 over 1. The 2's cancel. It's the square root of 3. In the second quadrant, the tangent is negative. So that is the exact value for that expression. Another example. Page 226, section 5.4, number 54. Find the value of s, the sine of s plus t, the tangent of s plus t, the quadrant of the angle s plus t given. Cosine of s is a negative 15/17, and the sine of t is 4/5. First of all, you have to recognize that the sine of s plus t is the sine of s, cosine of t, plus the cosine of s, sine of t. The tangent of s plus t is the tangent of s plus the tangent of t over 1 minus tangent s, tangent t. The quadrant, if we know what the sine, plus or minus sign of these two are, then we'll be able to figure out the quadrant. So, let's see here. First of all, s needs a bullseye. If the cosine is negative, then also we know, I guess, it's in quadrant 2. That was given. Sorry. So we're in quadrant 2. So the negative 15 is right here. We don't know what y is, but the 17 is the radius. T is in quadrant 1. So the sine is the opposite. So this is 4. 5 is the radius, and we don't know what x is. But we can figure these out. So a negative 15 squared plus y squared equals 17 squared. 225 plus y squared equals 289. And y squared equals 289 minus 225, which is, y squared is 64, so y must be 8. Is it positive or negative? It is a positive 8. Same idea here. We know this is a 3, 4, 5 right triangle. So x must be 3, positive 3. So now we can go back up to our problem at the top and use what we know. Let's see. The sine of s is the opposite over the hypotenuse, 8/17. 8/17. The cosine, oh, we're given that, -15/17. The cosine of s, oh, I'm sorry, that's what that one is. Gee, -15/17. But this one is not. So now I'm going to have to write over the top of it. T, I want the cosine of t, which is 3/5. Okay. But the cosine of s is -15/17. And the sine of t is 4/5. So you can multiply those out and get an answer for that. I'm running out of room though. But do notice, this is a positive times a negative. So this is negative plus a negative times a positive. This is negative. So we're adding two negatives. So we know that this is negative. The sign is negative. That means we'll be in the third or fourth quadrant. The tangent now. The tangent is the opposite over adjacent. This is a -8/15. The tangent of t is 4/3. 1 minus the tangent of s is a -8/15. And tangent of t is 4/3. And we can multiply that out. But notice, 4/3 is much larger than 8/15. So the numerator is positive. The denominator, we have a negative times a negative, so it's positive. So the tangent is positive, and that's in quadrants 1 and 3. So s plus t must be in quadrant 3. And once again, you can multiply these out. I'll probably on the test not require you to multiply those out. It'd be easier for me to grade to know that you are getting the right answer. That's number 54. Draw a picture. Trigonometry, section 5.4, page 226. Number 64 is verify the identity. I'm going to work on the left side and only the left side. Tangent of a difference. Let's see, that's tangent x minus tangent y over 1 plus tangent x tangent y minus, again, but now they've switched the x and the y, so it's tangent y minus tangent x over 1 plus tangent y tangent x. Okay, these are two fractions, but they do have the same denominator. You don't have to worry about the order here because it's multiplication and it's commutative. So, the tangent of x minus the tangent of y minus, better put some parentheses, tangent y minus tangent x over that common denominator, 1 plus tangent x tangent y. Okay, let's see, let's distribute that negative. Tangent x minus tangent y minus tangent y plus tangent x over, common denominator, 1 plus tangent x tangent y. Well, in fact, that's what we want in the denominator. Hopefully this numerator is going to work out. So I've got a tangent x and another tangent x, so there's two tangent x's. Got a negative tangent y and a negative tangent y, so there's a -2 tangent y over 1 plus tangent x tangent y. Factor out that 2. 2 times the quantity tangent x minus tangent y over 1 plus tangent x tangent y. And that's what we're trying to get. QED. Trigonometry. Section 5.4, page 226, example problem number 68, verify the identity. Okay, it's important to make sure you work on only one side and move that down. We're going to work on the left And don't do anything on the right until right at the end when you match this one. You've got to, if you want, put down some thought bubbles or something to show why something is true, or just take very small steps as you go. So I'm going to work on the left side. What is the identity for the sine of a sum of two angles? Let's see. Sine of x cosine y plus cosine x sine y over, what's the cosine of a difference? Let's see. Cosine x cosine y plus, because this is opposite sign, sine x sine y. Okay. Now, this one is sort of takes a trick. You need to always keep in mind what you're trying to get. This side is a cotangent, right? And remember, and that's where you can put sort of a thought bubble, that the cotangent of some angle is the cosine of that angle over the sine. So I need to really have a sine in the denominator of all these. And some things will cancel and some will make cotangents. So I'm going to divide everybody by this sine x sine y. So sine x cosine y over sine x sine y plus cosine x sine y over sine x sine y over cosine x cosine y over sine x sine y plus sine x sine y over itself sine x sine y. Now, a lot of things cancel. I'm going to use a different color to cancel. So this sine x cancels that sine x. This sine y cancels that sine y. None of these cancel, but both of these cancel. So now you get cosine y over sine y plus cosine x over sine x over cosine x over sine x times cosine y over sine y. Plus, well, these cancel, but that doesn't disappear. It becomes 1 then. And now, because we needed cotangents, this is the cotangent of y plus this is the cotangent of x over, now I'm going to put this 1 first because addition is commutative. So I'm going to put the 1 first because that's what I need, and I'm running out of space. And I need then cotangent x plus cotangent x, cotangent y. And that is what we wanted, QED. Trig, section 5.4, example problem, number 72. From number 71, we have this formula, f equals 0.6 w sine of theta plus 90 degrees over the sine of 12 degrees. For this, part A, they're saying this, we're supposed to calculate F if W equals 170 pounds, that's the pound of the weight of a person, and theta equals 30 degrees. So the force that it is used to pick that up. So plug that in, 0.6 times 170, the sine of 30 degrees plus 90 degrees over the sine of 12 degrees. Let's see, 0.6 times 170 is 102. The sine of 90 and 30 is 120 degrees over the sine of 12 degrees. Now you can put that in your calculator. You will get 0.866 over 0.2079, that's times the 102, and finally 4 to 4.87 pounds is the force. You're supposed to round that to the nearest whole, so 425 pounds. Part B. They want to know what angle you would need, theta, using the same formula, if you wanted the force to be 400. 0.6 W is 200 pounds. Sine of theta plus 90 degrees over the sine of 12 degrees. You can do this several different ways. All of these values give you some numbers. You can then, they said, I think, to graph this with your graphing calculator. So put the 400 into y1, and in y2 you're going to put the 0.6 times the 200. The sine, you can't use theta, you'll use x plus 90. Close this, you have to open and close this because it's the numerator divided by the sine of 12 degrees. You don't put the degrees, just 12. Make sure you're in degree mode. Press the mode button, make sure it says degree. When you graph these two, you find out where they intersect. You have to make the appropriate window. And I'll let you try to figure that out a little bit on your own. Remember, this is going to be at 400, so y max has got to be at least 400. And you might have to see where these two things cross then by making your window larger. But then you can go to second trace, which is really the calc menu. And number 5 is intersect. First curve, press enter. Second curve, press enter, because you only had 2 curves on there. For the guess, use your arrow keys to get close to where they cross and press enter. You should get theta, I guess our x is 46.1 degrees.